Hi everyone, welcome back to Soil Science Laboratory. This is the last part of soil chemistry. Today we're gonna learn how to analyze available phosphorus and extendable potassium. Let's start with available phosphorus. Today we will determine the amount of phosphorus that available in soil. Therefore, we won't measure all the total phosphorus in soil, but some part of phosphorus that can be used by plant. The method for available phosphorus called molybdenum blue method. We will make the solution by colorimetric. The specific color compounds are formed with the addition of appropriate reagents in the solution, and then we estimate the intensity of solution, which is proportionate to the concentration of the element. And the color intensity is measured by spectrophotometer at 660 nanometer. The principle of this method is we will use extract reagent called Lab3. We use Lab3 to extract some part of phosphorus in soil. But there are many extracting reagents, for example, Lab1 and ozone reagent. But for this laboratory, we will use Lab2. There are some reagents that we need in this method. The first one is extracting solution called Lab2, which is the combination of dilute hydrochloric acid and ammonium fluoride. This extracting solution is used to extract available phosphorus from soil. The second reagent is the color developing reagent called molybdenum. The third one is cyanide chloride, which used as a reducing agent. And the last one is the stock standard solution of phosphorus 100 ppm. For the first step, we will do the extraction and filter it. So you already have the soil sample, which is air dry and passed through 2 ml sieve. Then you weigh 1 gram of soil into an extraction bottle or the centrifuge tube, and then add 7 ml of the extracting solution, and then check the container by hand 1 minute exactly. After 1 minute, filter the contents through the filter paper. Next step, we're gonna prepare the standard curve by take 1, 2, 3, 4, 5 milliliter of the 100 ppm of stock standard solution of phosphorus and dilute it with distilled water into 100 milliliter volumetric flask. This solution contains 1, 2, 3, 4, and 5 ppm of phosphorus. Then put 2 ml of each concentration of phosphorus standard into the test tube. Then add each tube with 2 ml of the extraction solution, which is the fresh Lab2. After that, we will add the ammonium molybdenum, 2 ml, and then add distilled water 3 ml each tube. Finally, we will add 1 ml of dilute cyanide chloride solution. Then check it. So the final concentration of each tube is 0, 0.2, 0.4, 0.6, 0.8, and 1 ppm of phosphorus. And the next step, we will prepare the test sample. So we will have the 4 tubes of sample. The first one is blank, which add 2 milliliter of extracting solution, which is fresh. And for the other samples, we will add 2 filtrate solution. Then we will deliver 2 milliliter of molybdenum reagent and add 5 milliliter of distilled water. And finally, we will add 1 milliliter of cyanide chloride. And after that, we will analyze the absorbent by spectrophotometer, and we will can calculate the concentration of the sample by the linear equation. Now I will show you how we prepare the test sample by deliver 2 milliliter of the filtrate in each tube of test sample. And for the standard set, we will take 2 milliliter of each concentration into each tube. You can see the 6th tube, which is 0, 0.2, 0.4, 0.6, 0.8, and 1 ppm of phosphorus. And then add ammonium molybdenate, add distilled water, and finally we add cyanide chloride, and then check. So you can see the blue color of the solution, which is the intensity of the solution is the proportionate of the concentration. So you can guess that for the last tube, the intensity of the solution is the highest. So this is the standard set. Then we will add cyanide chloride in the test sample. After 10 minutes, read the blue color of the solution on the spectrophotometer at a wavelength of 660 nanometer, and then plot the absorbent reading against the concentration of phosphorus. So you will get the linear equation from the graph. And after reading the standard, read the blue color of the test sample, and then you can calculate for the concentration of the sample from the linear equation. Here is the standard curve and the linear equation, which is y equal to 0.0429x with the good correlation coefficient nearly to 1. And I will give you your result in Excel file which share in the Microsoft team, and I would like you guys to calculate the concentration of phosphorus in your soil sample and report as the available phosphorus. And remember that the concentration that you calculated from the graph or from the linear equation is the concentration in 1 gram of soil. So you have to change the dimension of phosphorus and report as a milligram per kilogram of phosphorus. Okay, and I need you to interpret your result using the information that I give you in the handout. In the comment, I will give you some. You can use the information in the comment and report as the if you guys has the 7 milligram per kilogram available phosphorus, which means is low or high phosphorus in the soil. Okay, and this is all for the phosphorus analysis. Now we're going to the last part of soil chemistry laboratory, which is exchangeable potassium. The exchangeable potassium is some potassium which is free to exchange with the cation in the soil solution. The amount of potassium exchanged from the soil depends on the nature of the replacing solution. And the exchangeable potassium is defined more specific as the some part that extracted with the neutral 1 molar of ammonium acetate minus the water-soluble potassium. So in the non-saline soils, the amount of water-soluble potassium is very small, so we can ignore it. But in the saline soil, the water-soluble potassium should be determined from the saturated extract, which we can analyze from the laboratory one from the saturated phase of soil. And then a similar extract and the subtract from the potassium found in ammonium acetate extract. After extract soil with the 1 molar of ammonium acetate, potassium can be determined by flame photometer or atomic absorption spectrophotometer. The reagents that we need, the first one is ammonium acetate 1 molar. Prepare by add 58 ml of acetic acid mixed with 70 ml of ammonium hydroxide. Cool the solution and adjust pH to 7 with acetic acid or ammonium hydroxide using a pH meter, and dilute the solution to the volume, mix it and store it in the Pyrex or polypropylene water. The second one is the standard potassium solution 1000 ppm. Prepare by dissolve 0.9533 gram of dry potassium chloride in water and dilute to a solution to 500 ml and mix it. There are two methods to extract the exchangeable potassium from soil, both using the 1 molar ammonium acetate. The first method is repeated washing and centrifugation, and the second method is the continuous leaching using Bushnell funnel. And today we will study the Bushnell funnel procedure. For the Bushnell funnel procedure, we will use the air-dry soil which pass through 0.2 mm sieve, and then weigh 10 gram of soil in the aluminum flask, and then add approximately 40 ml of 1 molar ammonium acetate, swirl and let stand for 1 hour and more. And then after that, filter the mixture on a Bushnell funnel filled with filter paper connected to the suction flask. And then wash the soil by adding 10 ml portion of ammonium acetate. We will wash the soil by ammonium citrate until the approximately 90 ml has been collected in the suction flask. After filter process, we will pour the extract into a 100 ml volumetric flask. Make up the volume by rinsing the suction flask with fresh 1 molar ammonium citrate and mix it. We will analyze the extendable potassium by atomic absorption spectrophotometer using a wavelength of 766.5 nanometer with an air acetylene flame. A sensitivity of about 0.04 microgram per milliliter can be expected. A 2 ppm sample will give a reading of about 0.22 absorbance unit. We will use the standard set of 0, 0.4, 0.8, 0, 1.2, 1.6, and 2 ppm. And the curve should be linear to about 2 ppm. And oxidizing flame is recommended. So we'll prepare the standard set and read the absorbance, and we will plot the graph of the absorbance and concentration. And after that, we will analyze for the sample, and we will got the absorbance of the sample, and we will calculate the concentration of the sample using the linear equation. After reading the sample, we will got the standard curve, and we have the linear equation, and we can calculate the concentration of the solution. And I will give the result in the Excel file, which is shared in the Microsoft team as the same as the phosphorus result. And you guys have to calculate the concentration of the potassium. And remember that the concentration that I will give you is the concentration in 10 gram of soil. You have to change the dimension into the milligram per kilogram of soil and report it, and do the same way as the phosphorus laboratory. And so this is done for the soil chemistry part. Thank you for your attention. And if you have any question, you can ask me in the Microsoft team. Bye bye.